So hello everyone. So welcome to this session. So in the last class we have discussed about the applications of differential equations in Z transforms. So before we get to the problems related to that, we will solve a few more problems related to partial fractions, which are very important ones. Okay. So in this session I am going to solve two important problems of partial fraction, and in the next session we will start with the differential equations problems. Okay, so this is the question. Z inverse of z square plus z divided by z cube plus 6z square plus 11z plus 6. So now let's solve this. So now this is not of the form of partial fraction, as we have solved one problem related to that, right? So for this we need to take the synthetic division. Okay, so now let's apply the synthetic division. Let's apply the synthetic division. Let's take the coefficients of this term, that is 1, 6, 11 and 6. So the first root, we need to write it here. The first root is that whatever we need to fill the z value such a way that the answer we get is 0. So I've already done that. So you need to put this equation in the calculator, and you need to find the first root. So the first root which I got is -1. Okay. So now nothing much to do. This 1 you should bring down, then multiply -1 with this term, that is -1 into 1 is -1. 6, we need to add these two terms, that is 6 plus 1, so 6 minus 1, so it is 5. -1 into 5 is -5. 11 minus 5 is again 6. -1 into 6 is -6. So this term, the last term which we got, is 0. Okay, this we need to get, we should get this last term as 0 always. So now with these terms, let's write the quadratic equation, that is z square plus 5z plus 6 is equal to 0. So now again we need to find the other two roots by using the quadratic formula. Okay, so now let's use the quadratic formula. As we know that the quadratic formula is minus b plus or minus b square minus 4ac the whole root by 2a. So we'll apply that. Here the value of b here is 5, right? So minus 5 plus or minus square root of 5 minus 5 square is 25, minus 4 into 6 into 1, that is 24, divided by 2 into 1, that is 2. Okay, minus 5 plus or minus 1, square root of 25 minus 24 is 1, and square root of 1 is 1, 2. So z equal to minus 5 plus 1 by 2, or minus 5 minus 1 by 2. So the value of z we get is, this is minus 5 plus 1 is minus 4 by 2, that is minus 2, comma minus 6 by 2, that is minus 3. Okay, so finally we get these three roots, that is minus 1, minus 2 and minus 3. So the following z inverse, the question would be looking like z plus 1. Since the root which we got is minus 1, right? So always we need to write it as z plus 1, z plus 2 and z plus 3. Okay, so these are the three roots which we got. So now in this we need to simplify this term using, the partial fraction. So now let's solve it. So we know that the equation would be is z divided by z plus 1. Since the power is 1, right? So we need to multiply the numerator by z plus bz by z plus 2 plus cz by z plus 3. Okay, so now in order to cancel these terms, we need to take the LCM. So the LCM, by taking LCM, the term which we get is z plus 1, z plus 2, z plus 3. So these are the terms which we get, because by taking the LCM, there is only z plus 1, right? But we need other two terms. So which are the missing terms here? Z plus 2 and z plus 3. So we need to multiply that. The same thing here. Z plus 2 is there. We need to multiply z plus 1 and z plus 3. Same goes with cz. Okay. So now the remaining terms are z square plus z equal to az into z plus 2, z plus 3, bz into z plus 1, z plus 3, cz into z plus 1 and z plus 2. So now here we can see that we can take z common, right, in both LHS and RHS. So we will take that out so that we can cancel that z. So the remaining term here is z plus 1 equals to z into a z plus 2, z plus 3 plus b z plus 1, z plus 3, z plus 2. So here again we can cancel this z, so the final equation which we get is z plus 3, b z plus 1, z plus 3, c z plus 1, z plus 2. So this is your required equation. So take this as equation star, this as 1. Okay. So now we know that we need to find the values for a, b and c. So we can find, this is a straightforward question. We no need to compare any coefficients. So to find the value of a, we need to make these two terms equal to 0, and which is a term common in these two terms, that is z plus 1, right? And here in order to make this term, two terms equal to 0, we need to substitute the value of z as minus 1, so that this becomes 0, and also here also minus 1. So in the first case, in order to find the value of a, we need to put the value of z as minus 1. Okay. So I have substituted the value of z as minus 1. So we know that this will become b into minus 1 plus 3 plus c into minus 1 plus 1 minus 1 plus 2. Here also we can cancel these two terms because minus 1 plus 1 is 0, and 0 into these both terms also becomes 0. Same goes with this. So the remaining term is, this becomes 0, a into minus 1 plus 2 is plus 1 and minus 1 plus 3 is plus 2. So the 0 equal to 2a. So therefore the value of a which we get here is 0. Similarly, find the values for b and c. In order to find the value of b, we need to put the value of z equal to minus 2. Okay. So the following equation becomes minus 2 plus 1 equal to a into minus 2 plus 3 minus 3 plus 3 plus b into minus 2 plus 1 minus 2 plus 3 plus c into minus 2 plus 1 into minus 2 plus 2. So this is equal to 2. Okay. So now we can cancel these two terms because minus 2 plus 2 is 0 in both the cases here. So the remaining term is minus 2 plus 1 is minus 1, b into minus 2 plus 1 is again minus 1, minus 2 plus 3 is 1. So minus 1 equal to b into minus 1 into 1 is minus 1. Therefore the value of b equal to 1. Since minus b equal to minus 1, so we can write it b equal to 1. Okay. So similarly find the value for c. To find the value of c, again we need to put the value of z as minus 3. So the equation is minus 3 plus 2 plus b into minus 3 plus 1 minus 3 plus 3 plus c into minus 3 plus 1 into minus 3 plus 2. So we can cancel these two terms because minus 3 plus 3 is 0, right? So minus 3 plus 1 is minus 2. C into minus 3 plus 1 is again minus 2. Minus 3 plus 2 is minus 1. Minus 2 equal to C into minus 2 into minus 1 is plus 2, so minus 2 equal to 2c. Therefore the value of c which we get here is minus 1. So we got the values for a, b and c. So now substitute it in equation star. So here I have substituted the value of a, b and c. So now we need to take z transform as a inverse z on both sides, so that we can get the z inverse. Z inverse of this term we can neglect it, we can write it as 0 because 0 is there, right? So let's start with this term itself. Z inverse of z by z plus 2. This 1 I have taken outside here, you can write it as 1 minus 1 into z inverse of, so z inverse of z by z plus 3. Okay, now we know that it's of the form z by z minus a. So in place of here it is z plus 2. So this can also be written as z minus of minus 2. Here also z minus of minus 3. So here we can say that the value of a here is minus 2. So the answer is minus 2 power n minus of minus 3 power n. So this is a required z transform. Okay, so we'll solve one more important question. So this is your next question. Z inverse of z cube minus 20z divided by z minus 2 whole cube into z minus 4. So now we need to split this very carefully into a partial fraction. We know that the first term which we need to write the first power of this z minus 2 the whole cube, that is a z into z minus 2 plus b into, now we need to write in the denominator z minus 2 whole square, right, till we reach z minus 2 whole cube. Okay, so we know that if in the denominator it is the square term, so we need to multiply the numerator by az. So the value of a here is 2, so 2z plus c into, again for the cube term, the az square plus a square z, we need to multiply it by az square plus a square z. So by substituting we get it as 2z square plus 2 square z, that is 4z divided by z minus 2 whole cube. So there is one more term, that is z minus 4, that we can write it directly, dz divided by z minus 4. So name this as equation star. So now let's make the denominators equal by taking the LCM. So z minus 2 whole cube, z minus 4. So the first term is, we have z minus 2. So the remaining terms here are z minus 2 whole square and z minus 4 plus 2 into b into z, 2bz. Here there is z minus 2 whole square, but here it is z minus 2c, so one z minus 2 term is missing along with z minus 4 plus c. Let's take in this term, let's take z common outside from this 2z square plus 4z, because we can cancel, while cancelling the denominator we can cancel, we can take z common on both sides, since we have z common in case of a, b and c and d. Okay, so from this let's take z outside and let's write 2z plus 4, right, into, we have z minus 2 whole cube, so the term missing is z minus 4 plus dz into, we have z minus 4 but z minus 2 whole cube is missing, z minus 2 whole cube. Okay, so we can cancel the denominator. So this is one single term, okay, this is whole divided by, so don't confuse it. So now the remaining terms are z cube minus 20z equal to az into z minus 2 whole square z minus 4 plus 2bz into z minus 2 into z minus 4 plus cz into 2z plus 4 into z minus 4 plus dz into z minus 2 whole cube. Okay, so now let's take the z outside and cancel it. Yeah, So we have written it. So in order to consume time, I am just pausing and writing the steps for you. Okay, this is a simple. We have done many problems, right? I've cancelled. I've taken z common in both LHS and RHS, and I've cancelled it, and I've written the remaining equation. Okay. So now here we need to find the values for A, B, C, and D. We need to find all the 4 values for A, B, C, and D. Okay. So here we can see that we can find the values for C as well as D. Because for C we have 3 terms common here, C z minus 2, z minus 2 and z minus 2, and also for D we have 3 terms common, that is z minus 4, z minus 4, z minus 4. So we cannot find the values for A and B. So for that we need to compare the coefficients and find it. Okay, so let's solve it. First we'll find the value for C. In order to find the value for C, we know that z minus 2 is common, so we should put the value of z as 2 to make it 0, right? So put z equal to 2. So in the equation, I'll directly write skip one step and I'll write it. So 2 square minus 20. So z square minus 20, 2 square minus 20, that is 4 minus 20 equal to. So A into this term will become 0. So automatically the term left is the C term, right? So we know that these 3 terms will be 0. So I'll write the C term directly. C into 2 into 2 plus 4, that is 4 plus 4 into 2 minus 4. So 4 minus 20 is minus 16. C into 4 plus 4 is 8. 2 minus 4 is minus 2. Minus 16 equal to C into minus 16, right? So this we can write it as C equal to 1. So similarly to find the value of D, we need to put the value of Z as 4. See, Z minus 4 is common, so we need to put the value of Z as 4. Z equal to 4. So 4 square, Z square minus 20, 4 square is 16, 16 minus 20 is 16 minus 20 is equal to minus 4, right? Okay. So the D term only will be remaining, since all the 3 terms will be cancelled out, since 4 minus 4 is 0 in these 3 cases, so I am not going to write that. So the D term left is D into 4 minus 2 whole cube. 16 minus 20 is minus 4. D into 4 minus 2 is 2, 2 cube is 8. So 4 equal to, minus 4 equal to 8D, therefore D equal to minus 4 by 8, 4 1s are 4 2s are, therefore D equal to minus 1 by 2. So now we found the values for C and D. Let's find the values for A and B by comparing the coefficients. So first, by doing the comparison of coefficients, we need to see the highest degree, and we need to start with the highest degree. So in this question, the highest degree is z minus 2 the whole cube, right? So we need to compare the coefficients of z cube first. Okay, so now let's compare it. In the left hand side it is z square, so automatically it is 0. So we have A into z minus 2 whole square into z minus 4. So while multiplying it again, we will get the z cube term as the highest term, because z minus 2 whole square into z minus 4. So here if we expand this, we get it as z square minus 4z plus 4, right, into z minus 4. So if we multiply this, if we again further multiply, if we multiply this z square into z, then it becomes z cube. So we got z cube as the highest degree, so we need to consider that. So z cube is there, outside A is there, so A, right? So in the place of B term, there is no cube term, also in place of C, but in place of D we have z minus 2 the whole cube. So yeah, we can write it as A plus D. So 0 equal to A, the value of D we found it, that is minus 1 by 2. Therefore A equal to 1 by 2 by comparing the coefficients of z cube. So now to find the value for B, right, we no need to compare the coefficients, we can directly put the value of z as 0 in equation in equation 1. So how we can put the value of z as 0? Since we have found already the A, C and D. So if we put the value of z as 0, automatically the remaining term left is D, right? We can easily find the value of D. Okay, so put the z equal to 0 and find the value of B. Okay, so left hand side becomes z square minus 20. So 0 square minus 20 is again minus 20 equal to A into z minus 2 whole square. That z term goes, so the remaining term is minus 2 square into z minus 4. So minus 4 plus 2b into z minus 2. Z equal to 0. So minus 2 plus c into 4 into minus 4. Since 2z plus 4, right? 2 into 0 plus 4, so it's 4 plus d into minus 2 whole cube. So now let's solve this. Simple maths, we need to simplify it. Minus 2 whole square is plus 4. 4 into minus 4 is minus 16a plus minus 2 into minus 4 is 8. 8 into 2 is 16, so 16b. 4 into minus 4 minus 16c, and minus 2 cube is minus 8d. Okay, so now substitute the values for A. We got the value of A as 1 by 2 plus 16b, keep it as it is, we are going to find it. Minus 16 into the value of C is 1, minus 8 into the value of D is minus 1 by 2. So 2 1s are 2 8s are, 2 1s are 2 4s are. So 8 into 1 is 8 plus 16b minus 16 plus 4, because minus 4 into minus 1, so plus 1. Minus 20 equal to 16b, so minus 16 minus 8 is minus 24 plus 4 is minus 20. So if we bring this minus 20 to this side, it becomes minus 20 plus 20 equal to 16b. So 0 equal to 16b, therefore the value of b which we get is equal to 0. Okay, so here we have found the values for A, B, C and D by these simplifications. Okay, so please make a note of this. So now we'll put these values in equation star. Yeah, so I've substituted the value of A, C and D. Since the value of B is 0, I have neglected that term. Okay, so now we need to take the Z inverse of, take this 1 by 2 outside, Z by Z minus 2 plus Z inverse of 2Z square plus 4Z divided by Z minus 2 whole cube minus 1 by 2 Z inverse of Z by Z minus 4. Okay, so here directly for these two terms we have the values for A as 2, so substitute it. 1 by 2 into 2 power n plus, here it's of the form a squared z plus az squared divided by z minus a whole cube, right? So the z inverse of that function is a cube, so n cube a power n, right? So in place of n we have here 2, so the value is n cube into 2 power n minus 1 by 2 into the value of here a is 4 power n. So here we can further simplify this. See here, so here we can write it as 2 power n by 2 plus 2 power n cube minus, in place of 4 write it as 2 square power n, okay, divided by 2. So we know that this is equal to 2 power 2n. If you want you can simplify, otherwise you can stop it here itself. So let's I am trying to write the further simplified answer. Okay, so here this is equal to 2 to the power 1, right? So bring this to the numerator, so this will, the power symbol will change, that is equal to 2 to the power n minus 1, right? Since the identity a power m divided by a power n equal to a power n minus n, right? Plus 2 power n cube. Here again 2 to the power 2n minus 1. So this is your required answer. Okay. So please make a note of these problems very clearly. So these two problems are very important, that's why I have solved it for you guys, and it's repeated in many of the question papers. So you guys please make a note of these problems, and in the next session I'm going to start with the differential equation problems. Okay, thank you.